So yesterday we have seen some points in NFPA 13 about the sprinkler and how to place, like we have seen some regulations from NFPA 13 that how to follow for location of sprinklers placement, because I think that in firefighting the most important thing is sprinklers only. Why means because the design of sprinkler is the most important, because in hydrant system you don't need to design anything, you just need to place hydrant. Hydrants can be placed anywhere, near the exits or near the corridor, wherever suitable position. And in every floor we have to place either 2 hydrants or 3 hydrants. In the same thing about the fire extinguisher also. But sprinklers we have to design properly, and we had a long conversation yesterday, and still some points are left out in sprinkler, like we were seeing this hydraulic, the procedure for hydraulic calculation. So from this chapter it will talk about the hydraulic calculation, and here only they have given one section here. uh, Hydraulic calculation forms something they have given here. If you observe this particular point, whatever the thing is given here, like hydraulic calculation shall be prepared on form sheet that include a summary sheet, detail worksheet, graph sheet. So everything will come in our allied software also. In this particular book, they have given their own format, like maybe in NFPA they are following this format for doing the calculation. So they have written, and they have also highlighted what is the summary sheet and what is the graph sheet, everything they have given here. So we don't need to study those things, because anyhow when we get the allied report, we will understand what we are going to get. Okay, so we will skip this portion and directly we will start from our calculation procedure. Here they have given the hydraulic calculation procedures. Okay, now here you see, here they have given certain what you can say, certain rules related to hydraulic calculation. A calculated system for a building or a calculated addition to a system in an existing shall supersede the rules in the standard pipe schedules, except that all systems shall continue to be limited by area. Okay, pipe sizes shall be no less than 1 inches. Here they have given clearly one clause. So here it is telling that the minimum pipe size what we have to follow for firefighting is 1 inches or 25 mm. So here we understood that the minimum pipe sizing will be our 1 inches. Okay, nominal for ferrous piping, and suppose if you are going with a copper piping, 20 mm will also do. Okay, so this thing they have given. However, sprinkler spacing or other rules covered in this standard shall be observed. Hydraulic calculation shall extend to the effective. Okay, some things are given. Now here they have given the friction loss formula. Now this is the Hazen-Williams formula. Okay, pipe friction losses shall be determined on the basis of the Hazen-Williams formula as follows. So whenever we are doing the hydraulic calculation, so the calculation, okay, now this formula we are going to follow in our manual calculation, hydraulic. But I think in the allied calculation also, the formulas are feeded. Maybe this is the only formula which is feeded in the allied software, because in allied software, we don't have to do any calculation. We just need to input the values. Software automatically will do the calculations. But this is the formula. Now remember, this formula is entirely different, Hazen-Williams formula, from the plumbing formula. Okay, like in plumbing also we can follow this calculation for pump head calculations, but that formula is entirely different. This formula is entirely different. So we don't need to mix those formulas. And here they have given P is the frictional resistance, Q is the flow. Okay, so this thing we will see in our hydraulic calculation class. And one more formula they have given. So maybe this is the formula we are following close to in plumbings. Okay, but here we are going to follow this formula in GPM or in pipes in the inches. So just remember this formula, because in our hydraulic calculation we are going to follow this formula. What is the meaning of friction loss? Friction loss means, just understand one thing, whenever there is a pipe, okay, whenever we are doing any pipe calculation obviously there will be friction. In the same way, if we are calculating for ducts, even in ducts also we will get friction. Okay, like if you are doing the calculation for cables, suppose if you are doing for cables, here also friction will come, but the name will be given as different resistance. So this is one parameter which will always available whenever you are doing any air calculation, water calculation, or current calculation. So this is one parameter. So we need to calculate this friction losses only, and different methods are given. For plumbing, the method is different. For HVAC, the method is different. For firefighting, the method is different. So that's why we are trying to focus here for the friction loss only. Mostly we have to calculate the friction losses. Rest everything will follow the sequence. They have given different formulas here. So some formula is given antifreeze solution. So this is Darcy's equation also given. Just avoid it, no need. Now here they have given one point. Pressure at hydraulic junction point shall balance within 0.5 psi. Okay, leave this. Here they have given the K factor formula also. Suppose if we want to calculate, now what is the meaning of K factor formula? Now K factor formula is very quick formula which we can use for anything. Like K is equals to, the formula is given as K is equals to Q divided by square root of P. Suppose if I am keeping my K as constant, suppose I am keeping my K as constant, which is 5.65. And suppose if my pressure also I am keeping as at constant, like 7 psi. So with these two values, I can easily calculate my Q value. Okay. So what you have to do, simply you have to write Q is equals to K. I think it will come square root of P only. So 0.5 it will go. Okay. This is the formula only we will get. So with this we can calculate K. And also I have written here also one example. I will show you. Just I have written one example here also. K factor, where is that? Okay, here it is given. Just a minute. So this is just for our cross section. Like if you want to cross check anything, so you can cross check with this K factor formula. See here, I have just written one example. In the software itself, in the software also you can do the K factor calculation. I will show you. In the Allied software also there is one section is given where you can cross check. If the K factor is this, what will be the flow value, what will be the pressure value, that thing you can do. So this is also one of the important formula, K factor. Now after that, there are two formulas used here. Next, they have given some section about the equivalent pipe length of walls and fitting. Now here we have to get the equivalent pipe lengths. Like in plumbing, in HVAC also we have to get the equivalent pipe length. In the same way, here also we have to get the equivalent.
That one at the fitting, elbows.
Yes. Exactly. Here they have given the chart. So we are going to follow this particular chart for equivalent length of fitting. So
what about the valves? What about the valves? If I have non-10 valves, non-control valve, there is losses, right? Also.
Well, what we are telling?
What about the losses in the valves? Non-return,
it is given.
Valve.
See here given butterfly valve, gate valve, swing check. T 90-degree elbow, 90-degree elbow, 45-degree elbow. Only these many fittings are given. So we will be following this particular table. And here they have given the values in inches. And okay, this value we have to take always, outside value. Whatever it is written 1, 2, 3, 4. So these values we are going to add up in our calculation. So this is one table. And after that,
what is the bracket next to the integer? 3, for example, open bracket 0.9.
I think it is in meter. This is in feet. This is in feet. This is in meter, maybe.
So bracket is in the meter.
Sorry, I think outside is the meter, inside is the feet. So it is something like that. It is given here. And here they have given the pipe sizes also. From 15 mm up to 250 mm, 300 mm they have given. So obviously, whatever the pipe size, we can get easily all the equivalent pipelines here. And some things are written here. You can just avoid this. Some things are written. Now this portion is talking about the calculation procedure. Now in the calculation procedure, there are two methods given actually. One is the design area method, one is the room design method. We are going to follow this design area method only. Okay. Sorry, density area method. Why means because we have the density area curve. So we are going to follow this density area method. So this density area method is one formula is written actually here. If you observe this point, one formula is written where the design is based on the density. The design area shall be a rectangular area having a dimension parallel to the branch line at least 1.2 times the square root of area of sprinkler operation. So this is the formula. So based on this formula, we can get the number of sprinklers, or we can get the number of sprinklers and the flow, everything we can get. This is the density area method. One method is given as room design method also. I don't know why, what is the use of this room design method. Let us see. Some things are written here. Where the design is based on the room design method, the calculation shall be based on the room and communication space, if any, that is hydraulically the most demanding. So maybe this is used for the demanding or demand or supply. Everything is like we are going for the supply mode only. So maybe for the demanding mode, but nothing is given about this procedure, about this room method. Anyhow, then they have given CMSA sprinkler, ESFR sprinkler method. For CMSA sprinkler, the design area shall be a rectangular area having a dimension. This is also the same density area method. This is ESFR method. For ESFR, the design area shall consist of the most hydraulically demand area of 12 sprinklers, consisting of 4 sprinklers on each of the 3 branch line. So here what it is telling that whenever your building is having ESFR sprinkler, design the hydraulic system for 12 sprinklers only. So here what we have to do, we have to select 12 sprinklers in ESFR whenever we are selecting the ESFR sprinkler, because here clearly they have given, and here we have to select the most hydraulically demanding, or the most what you can say, the last floor, last sprinklers we have to select. Gridded system. For gridded system, the designer shall verify that the hydraulically is being used. Okay, this thing is not required for us.
What is ESFR abbreviation for what?
ESFR is early separation fast response. These systems are used in industrial only. For industrial purpose, they are used actually. Because in industry there we require the special types of sprinkler, CMSA and ESFR sprinkler. Mostly in the storage type of building, you will find this kind of sprinklers only. Okay. Next, some point is written here, a minimum of 2 additional sets of calculation. Okay, yeah, this is also actually important point. A minimum of 2 additional sets of calculation shall be submitted to demonstrate peaking of. Now, normally what happens, this point will, what you can say, this point will be applicable only if your design is submitted to any approving agencies. Like I think in Gulf countries, they follow this thing. Like you have to select 2 locations. Suppose this is your building, for example. You are getting confused. This is your building, and one sprinkler here, one sprinkler here, and your riser shaft is coming from here, for example. Now the sprinklers are going here, sprinklers are going here. You are confused. You don't know which is the longest path. So what we have to do, we have to submit 2 reports. One report this, one report this. So the approving agency will check both the calculation results, and they will approve. They will tell, okay, you can go ahead with this calculation. So what you can do, just avoid this calculation and follow this calculation. Like that, I think in Gulf countries they are following, or if they are not following also, at least we should go for the 2 calculation sets so that the agencies can approve. Because obviously in any building there are 4 corners. So sometimes what happens, if you have not placed sprinklers like properly, then all the 4 places you will feel that you will not understand that which is the hydraulically most calculation. Then in that case, you have to go with 4 sides also. Okay, so it is for our safer side only. For our what you can understanding, we can go this.
The calculation would be based on the longest route, right?
Longest path, yeah. Based on the
Why we are confused if we know the longest path? Why we are confused for this four
see
size
here.
fingers calculation?
Here only they have given NFPA. A minimum of 2 additional sets of calculations shall be submitted to demonstrate peaking of demand area friction loss when compared to areas immediately adjacent on either side along the same branch line, unless the requirement of some things are given. Computer program that show the shall be accepted based on a single set of calculation. Even you can go with the single set of calculation also, because here it is telling computer program is nothing but allied software only, or any other software like pipenet, or if NFPA is using any software, so anything it can be. So this is what it is telling. As per this point, we understand this only. But at least if you do 2 sets of calculation, it will be helpful to you only, because no one will what you can say question us after we design. Okay, after this they have given design densities. So in the design densities, I think nothing is given. Design area sprinklers. Now this is the most important point here. Next, minimum design area. Now the meaning of this is minimum design area is that this is the minimum design area we have to consider. Suppose for example, whenever I am designing for light hazard, so the minimum area which I have to select is 1500 square feet, and ordinary hazard wet pipe system 1500, extra hazard wet pipe system 2500. Now we should not go below this, but sometimes what happens, you can, like sometimes your design is not you cannot select 1500 square feet. Sometimes it happens. So in that case, what you have to do, see, normally in hydraulic calculation, like if you are doing the hydraulic calculation for any intermediate level of building, intermediate means suppose 6th floor, 7th floor, or 8th floor building. So normally what we do means 6 to 12 sprinklers, and we select 2 hoses. So sometimes what happens, we don't bother about that 1500 square feet area, but we bother about 6 to 12 sprinklers. We will select, check how many sprinklers are coming in the longest route or in the most remote place. Sometimes it happens, but as per NFPA 13, it is given that the minimum design area we have to select always 1500 square feet. But sometimes it happens, sometimes it doesn't happen. Sometimes what happens, in your 1500 square feet area, you will get 16 number of sprinklers. So sometimes you have to do calculation for 16 sprinklers. Sometimes what happens, if I follow this particular standard, like 1500 divided by 225, because one sprinkler can cover 225 square feet. So I may get 7 sprinklers. So sometimes I can get 7 sprinklers. Sometimes I can get 10 sprinklers. Sometimes 12, sometimes 16. Any number can come. Sometimes I can go with the 6 number of sprinklers also. So it depends actually. Depends.
How you have the fixed area and you have fixed coverage? How it will jump from 7 to 10 to 12 to 16?
See how it will jump. I will show you. See, your 1500 square feet area will never be straight. Okay. Sometimes some obstructions will come. Anything can come in between. Yeah. I will check that. Yeah, minimum design area, I think is this only, what you have shared. So sometime what happens, your room will be like this. I will show you. Here staircase will come. Suppose for example, I'm talking about the longest path. Okay. And here lift will come, for example. And sometimes what happens here, one false ceiling will come here, this place. Now you tell me how you are going to select here. You have to check. Now you have to, suppose if I am going with only 3 sprinkler, 1 sprinkler for this area, 1 sprinkler for this area, 1 sprinkler for this area, this is also fine. So it can happen sometimes. In your 1500 square feet area, you have selected only 3 sprinklers. But again, it depends upon situation to situation. So that you need to always check. Okay. This is, yeah, this one only, the minimum design area. After that, Just remember this point, okay, because we have to always keep in mind everything, because these things, whenever you are going for any client interviews, sorry, for client discussion, anything, you can discuss this thing. After
Mr. Atif, less
some,
than 1,500 feet square, there is no sprinklers in the room?
it can never happen like that. You have to place sprinklers everywhere.
But it is mentioned minimum design area to omit discharge from sprinklers in small rooms.
Yeah. You have to go with the sprinklers. Otherwise, what is the use of doing hydraulic calculation if you don't have any one sprinkler? Okay. Now here something is given. Calculate the loss for T. Okay, leave these points. We don't require these things. Orifice places plates shall not be used for balancing unless the requirement. Leave this. This is the Hazen-Williams C values. Okay. We are going to use this 120 value because all the MS pipe and GI pipe C value is 120. Galvanized steel and black steel. So if suppose you are using, like if you are using this black steel, carbon steel, you can go with C value of 100. Otherwise you can use 120. If you are using cast or ductile iron, again 100. If you are using any plastic pipes, 150. Copper tube, 150. Asbestos, cement or concrete pipes, 140. Some values are given here. Minimum operating pressure. See here they have given the minimum operating pressure. The minimum operating pressure of any sprinkler shall be 7 psi. Where a higher minimum operating pressure for the desired is specified, the highest pressure shall be required. Maximum operating pressure for extra hazard occupancies, palletized solid pile. Okay, the maximum operating pressure of any sprinkler shall be 175 psi. Now just see this point. This is the minimum pressure. This is the maximum pressure for any sprinkler system. 7 psi, 175. Our calculation should be limited up to 175 psi only. We should not exceed 175 psi.
At the sprinkler head, 12 bar.
Yeah, not at the sprinkler head, near the pump. This pressure should be near the pump, sprinkler pump. 175 psi.
You mean the firefighting pipe?
Yeah, firefighting pump. If
that one is 0.5 bar at the sprinkler, this one.
This is the sprinkler head. This is the farthest sprinkler. The last sprinkler it should be. Pipe schedule shall not be used except in existing system and in new system or extension to existing system. Water supply shall confirm. Here NFPA is only telling that don't go with the pipe schedule. Maybe he is talking about the pipe schedule system only. Okay, leave this. There are so many clauses written, you can go through that. And next important thing, they have given the pipe sizes. Now this is the pipe schedule size we have to follow. For light hazard, if you are having 2 sprinkler 1 inches, 3 sprinkler 5, 10, 30, 60, I will explain you this, how we have to understand this. Steel and copper pipe sizing is given here. And in the same way, they have given some arrangement of sprinkler also, how the sprinklers are arranged, upright sprinklers, okay, and how this pipe size will be arranged, that arrangement is given. And also they have given the pipe sizing for, see, this is the pipe sprinkler placed above, below and in between false ceiling. This is the below false ceiling, this is the above false ceiling, this is in between false ceiling. So whenever you have a situation where you have to install sprinkler in between false ceiling, just check this image or explain to your installation team that you have to arrange sprinkler like this. Like this, you can show that. Number of sprinkler above and below a ceiling also it is given. Maximum 50 sprinklers you can connect. The pipe size will be 2.5 inches. 65 mm you can go with. This is the number of sprinkler above and below ceiling. Above and below ceiling means I think it is talking about the false ceiling only. In the false ceiling also you have to create sometimes network of pipe. So the maximum pipe size you can go with 65 mm in the false ceiling. Here the ordinary hazard pipe schedule is given, up to 8 inches they have given for the ordinary hazard pipe sizing. Steel and copper. Number of sprinkler greater than, okay, leave this. For extra hazard they have not given. Even here also they have given for ordinary sprinkler above and below a ceiling you can connect up to 3 inches. So just you have to remember this table, because whenever we are doing the calculations we have to always come back to this particular sheet and do our calculation. exposure protection. Okay, this thing is not required for us. What is given one, I don't know. Now next section it will talk about the water supplies, means how much water you have to supply to the building. So here also some clauses are written. Okay, they have not given anything. Maybe we can get one table for water supply. Hydrostatic test. Here they have given the hydrostatic test. The test pressure should be maintained at 200 psi and the test shall be conduct for 2 hours. So I have taken this point only. Okay, the maximum the maximum pressure of the sprinkler is 175 psi. Test pressure will be 200 psi. So just remember this thing. Minimum pressure is 0.2 psi. Maximum working system pressure is 175 psi. And the maximum test pressure is 200 psi or 14 bars, I think. This is something is given. And here also some points are given. Portion of system normally subject to system in excess of 150 shall be tested as described in this point at a pressure of 50 psi in excess. Okay, some things are given here, but this is the most important point which you can keep it in mind.
This is the pressure. This is the pressure test to check if there is leakage in the pipes, right?
Yeah. To check only for pressure. Pressure reducing valves also is given. Each pressure reducing shall be tested. Okay, leave this. And this is some certification and all has been given, which is not required for us. You can just skip. And some informations are given. These things not required. They will talk something about the marine system also. Like if you are designing for marine system, so you can go through that, because even I haven't designed this marine system. So that is the different thing. Next, one drawing is given actually here. So I'm trying to check that drawing only. So many things are given. Now, system inspection, testing and maintenance. Whenever you want to inspect testing and maintenance, go to NFPA 25. I think I have the NFPA 25 also. So I will share you I think I have already shared you. This is the NFPA 25. So this NFPA 25 will be for inspection, testing, maintenance, water-based fire protection system. Whenever you have to inspect, test or maintenance, do any maintenance work, just follow this NFPA 25 and nothing is given here. Just they have given the item frequency. What is the item? What is the frequency is given. Only this is given here. So, and here the good thing is that you will get each and every item here. What items are given for each system wise they have given, like foam water sprinkler system. For example, here they have given valve inspection. So many things are given here. You can just go through this. So many things are given here. This is NFP 25. They have clearly highlighted it. I think you can stop recording. Okay. Please clearly highlight. So this chapter is for the like maintenance. Just they have given one point. Then nothing is required. Next, how the graded system, loop system, those things are given. You can just skip this because these things are not required. So we will directly go down. So many unnecessary data are given here, which I don't think is like how to place the items and all. So many things are given, and this is, you see here. Here is the classification of buildings given: light hazard, ordinary hazard, extra hazard. This is the light hazard classification. This is the ordinary group 2, group 1, extra hazard group 1, group 2. This is the classification building given. So you can just follow this. Otherwise, nothing is given here. Just they have given so many things about the storage type of building again here also. So I'm just keeping this. Capacity of some structural data are given. Some they have given pipe valve installation also. Okay, leave this. Not required. These things are not required actually. Just some arrangements and all are given. So anyhow, we have the schematic drawing, so we will follow those arrangements. If we try to follow these arrangements, we will get confused. So that's why I'm just skipping these things. Some section they have given about the fire alarm also, like sprinkler fire alarm. So this section, if you want to go through this, you can go through this. Otherwise, we will be discussing this fire alarm topic separately. So that time we will discuss. This is the fire department connection. One fire department connection is given here. How you have to connect this fire department connection. This will come in different books also, in different standard also. City water pit arrangement. Okay. Now this is the most important thing what I wanted to show you. This is the zone control valve. Zone control valve. What is the meaning of zone control valve means? And in every floor, we have to give zone control valve.
Yes.
Yeah, because of zone control valve only, our whole system we can operate. And if sometimes maintenance purpose, you can go with this like zone control valve. You just switch off your zone control valve and you can go for the maintenance work, or you can also drain out the water. Suppose one test line will one drain line will be given here. If I close this zone control valve, I can easily flush out the water or drain the water from this particular floor. And again, I can test whatever I need testing. Suppose if pipe is broken, or suppose if sprinkler is not working, or anything if problems. So zone control valve is the most important. So this is one arrangement they have given. Normally it will have water flow switch, pressure gauge, and some butterfly valves will be there. Anyhow, we will see this zone control valve image in AutoCAD also. There are different types of images are given, like the drawings are given, so that we will see. Apart from this, this is the most important acceptable arrangement. Now, whenever we are going for the how we have to supply water to the how we have to supply water to the different floor. Here they have given one arrangement for combined sprinkler and standpipe system. So just remember this thing, because we will be explaining this later when we see the AutoCAD drawings. So that time you have to understand. But by saying this, you can understand that this is one pipe. This particular portion is going to the fire hydrant system. This particular portion is going to the sprinkler system. And this particular portion is coming from the sprinkler system for the drainage purpose. This is one arrangement and this is one arrangement. So there are two types of arrangement. So we will discuss this later. And here also they have given system test connection on dry pipe. If something is given. Apart from that, here you will find so many like fittings which are used in like to support the pipes and all. In this clevis hanger is like normally we like follow this also. And so many like threaded rods and all are given, common types of acceptable hangers. And some tables are also given, I think so. See, these tables are also given, but this all everything we will see in AutoCAD drawing. We have the standard AutoCAD dimensions table. Okay, so we will try to follow that only. Otherwise, you can check this also. There are so many things given. How to like fix the pipe, how much distance we have to keep between hanger and what you can say pipes, between two pipes. So many things are given. So I will just skip these portions. And this again, all the structural calculations are given here, which is not at all required for us. Some datas and all are given. These are all structural details actually.
These are in chapter 25.
We don't require this. They have just given some storage, they have just given some structural and some parts also.
These are in NFPA 25, section NFPA 25, right? These things?
NFPA 25 is only for the testing. NFPA 25 is used for what are the components?
The previous papers you have shown, in which in NFPA 13, right?
This is NFPA 13 only.
Oh, okay.
So many things are there. I am just skipping this because we will get confused if we start studying each and everything. Different like systems are given. Like this is the cooling tower. Now they have given a cooling tower, about cooling towers, and they have written some points about cooling tower. Then this is some preliminary plans and all. So many, like this is one set of calculations are also given in NFPA method. We don't need to follow this because we are anyhow following this one. What you can say, or what you say, light software method. So we don't need to bother about these calculations. Rest, nothing is given here apart from that. So just remember this, whatever we have seen. Okay, so mostly NFPA 13 is used for sprinklers, like some informations about sprinklers is given, and hydraulic calculation method is also given, like all the formulas, calculation steps, and what tables we have to follow, those things are given. And one section is given for the storage type of building. So this storage type of building we will see later. Okay, so this is something about the NFPA 13. Now let us go to the NFPA 14 also. And in NFPA 14 also, very few things are given. Like basically in NFPA 14, they are talking about the hydrant system. Okay. Now hydrant system is nothing but fire hose. Okay, whatever the fire hose system. So that is the hydrant system. Let us focus on that. Some points are given here. It's a very small book. 46 pages is only given here. So just skip. Some conversions are given. So I have just highlighted the conversion. So we will directly come to the main point here. So here some definitions and all are given, which is not required for us. Some important point is given about the fire department connection. Okay. For fire department connection shall be listed for a working pressure equal or greater than the pressure requirement of the system demand. Now this is the most important point. Fire department connection, pressure should be always greater. Why means because see our main system pressure is 175 psi. So either the fire department connection should be 175 psi. That means it can hold 175 psi, or it should be greater than 175 psi. Should not be less than 175 psi as per this particular point. What we are seeing, each fire department connection shall have at least two and a half fittings. Okay. Now
this is the two-way bridge.
Two-way bridge. Yeah. They have given the size also clearly that we have to follow 65 mm. But sometimes we can go with 40 mm also because it is also available in market, 40 mm. So here they have clearly given this point. And sometimes, okay. Now here it is talking about the system requirement. So these things are not required actually. Some clauses are given. So I have not highlighted. Again, system air pressure shall be maintained in accordance with the system. In suction sheet furnished with the dry pipe valve or shall be 20 psi. You remember, if you have seen this thing, we use one more equipment actually, one air tank we use in the system, firefighting system. It is sometime called as cushion tank or something. So this particular point is talking about that particular system only. One air tank or something. Why means because whenever we are talking about the water system, so we should have at least one air, what you can say, to remove the air, we have to use one system. Any one tank we have to use, just because what happens whenever water is flowing in the pipe, there may be chances of entrapment of air. Okay, this is 100%. There will be chances. So that's why it is called as cushion tank, I think so. Sometimes different names are given, air cushion tank or something, but we don't need to bother about the calculation because we will just contact manufacturer and we will take one equipment, like one machine. So it is already predetermined from the manufacturers. So maybe they are talking about this. And here they have given the classes of standpipe system. Now standpipe system is nothing but the the hydrant system only. Sometimes it is called as standpipe system also. So how to understand the meaning of standpipe system is simple. Suppose if this is my building and these are the floors, for example. Now in every floor, for example, I have two hydrants. Okay, one hydrant here and one hydrant somewhere here. So what I will do, I will just connect this two hydrant system with the standpipe. So one pipe will come and it will directly like connect. Again, it will go interconnect with this particular hydrant. Same way it will connect here and it will interconnect with this. So this particular arrangement is called a standpipe system, because here what is happening, one pipe and it is connecting to the hoses. Yeah, this is hose reel.
Hose reel, right? Yeah.
This is hose reel. So this is one standpipe system.
Okay.
Sometimes you have to go with two standpipe system, like one standpipe for that, one standpipe for this. So like that also, like one pipe is nothing but it is called a standpipe system. So normally this is how here they have classified the standpipe system. Class 1, class 2, class 3. The simple definition of class 1 pipe is that if the pipe size is 2.5 inches, see, class 1 standpipe system shall provide 2.5 inches hose connection. Whenever you are going to the hose, okay, near the hose, we have to connect one pipe actually here. So this diameter will be 65 mm. So this is talking about this. Let us check here also. So hose connections will come in two sizes only, either 40 mm or 65 mm. So if I write hose connection, let us see what it will show. So whenever this hydrant system, if the pipe is connected here, and if this pipe size, if the size is 65 mm, it is called as what you can say class 1 pipe. Okay. Hose connection in firefighting we will write. Maybe see, this is how the pipe, the connections will be made actually. And if you check this somewhere, see, if you see this, so beside what you can say, behind this particular arrangement, the pipe will be connected, and this inside hose will be there, like one what you can say, rubber RRL hose will be there. So that is a different thing. So we need to think about this only, 65 mm or 40 mm. So here clearly it is telling that when your hose connection size is 65 mm, it is called as class 1. If next second class 2 is nothing but if the hose connection size is 40 mm, it is called as class 2. Class 3 is the one where you have two, like two, one is 65, one is 40. Okay, this is the simple, but mostly we are using following the class 1 system only, because most of the hose diameters are 65 mm only. If it is 40 mm, then we can go with class 2, but mostly it is class 1 only, class 1 system. And here it is telling that a minimum 1 inch hose shall be permitted to be used for hose station in light hazard occupancy where investigator listed for the service. Okay, so maybe this it is talking about this nozzle. One nozzle will be used here, 25 mm. So okay, here this nozzle. So maybe this particular nozzle, it is talking about 25 mm. But the main supply pipe should be 65 mm or 40 mm. Okay. And here some points are given here. Required type of system. Okay, these things, these are some clauses which is not required. You can go through these clauses. I'm just focusing on the most important points here. Class 2 and class 3. Somewhere it will talk about the water flow. There are so many clauses given here. And here,
Engineer Atif, for the standpipe, is it a backup in case of one of the risers of the pipe fail, the other will continue supplying water? Is this the major reason for having two riser pipes left and right for the hose reel?
no, not like that. Because in every floor we have to use two hoses. Because floor is very big, one hose cannot cater all the water supply to that floor. So that's why we use two pipes. Just
maximum 30 meters. Maximum 30 meters.
No, 36 meters also you can use, 40 meters also you can use. So it's you have to check the length of the building actually, length of the floor. And if it is going more than 40-50 meters, then it's suitable to go with two hose reels. If you are using only one hose reel, means it cannot cater the building needs, complete floor needs, it cannot cater. So that's why most of the project you will go with two hose reels only. And sometimes what happens, you cannot
On
connect
the corridors.
corridors or staircase anywhere. Sometimes you cannot connect with one pipe because of some coordination issues. So they will go with the two pipe systems. Mostly what they will do, they will run all the like this pipe for both the hydrants they will run. So that's not an issue. And here they have given some clause also according to that. Now here they are talking about the location of fire department connection, where we have to keep the fire department connection or FBIC, the bridge inlet. Fire department connection shall be visible and recognizable from the street or nearest point of fire department. Accessibility on the street side of building. Fire department connection shall be located and arranged so that the hose lines can be attached to the inlets without interference from nearby object. Now suppose in case of any fire, so what we have to do, in case of any fire, the firefighting team will come and they will try to find our breaching inlet only. If we have placed our breaching inlet very securely, privately, it is not visible, then how firefighting team will, what you can say, like extinguish the fire. So that's why this point is telling that your hose connection should be, it should not be interference with any nearby objects or any fences, posts, landscaping, vehicles, anything. Okay. And here they have written some points. Okay, these are some points which is followed or not followed. It's okay. Each fire department connection shall be designated by a sign with letter at least 1 inches. You have to write standpipe so that the team will come and they will recognize, because what happens, sometimes the yard hydrant and fire department connection both look same. We cannot recognize because yard hydrants are also red in color and fire department connections are also in red in color. So that's why maybe they have given, you have to just identify, just you have to write down the name. This is your fire department connection. If automatic sprinkler also supplied by fire department, the sign of combination of sign shall indicate standpipe and auto sprinkler, standpipe. Okay, these are the things which, and here they have given fire department connection shall be located not more than 100 feet from the nearest fire hydrant connected to an approved body. Where a fire department service multiple building, a sign shall be provided indicating the building structure. Okay, some points are given which I think you will understand it. Fire department shall not be less than 18 inches, not more than 48 inches above the level of the adjoining ground. They have given the height of the fire department connection also from 18 inch up to 48 inches, because everyone can accessible it. Even a small boy, if fire occurs, even that small boy can access that fire department. That's why they have given the minimum height of 18 inches and maximum height is 48 inches. It should not go 40, because if you are placing in a higher, what you can say, at a higher height, and in case of fire, if someone is not reaching there, means what is the use of installing this fire department connection? Okay, some points are given here. Now this is the most important point. Maximum pressure at hose connection. Now pressure limit
4.5 bar.
Yeah, now you see here they are talking about the maximum pressure at any point in the system at any time shall not exceed 350 psi. Now just try to relate everything. Till now we have seen about the sprinkler. In the sprinkler they have given the minimum pressure of 7 psi,
0.5 bar up to 175 maximum.
175 psi. But in this hydrant it is telling that the maximum pressure is 350 psi. Just by seeing this point, the maximum pressure at any point in the system at any time shall not exceed 350 psi. So maybe when you are having what you can say, this is 24 bar. When you are dependent on the hydrant system, so this is the maximum pressure. When you are dependent on the sprinkler system, this is the maximum pressure. And this is the pressure for the system, not for the individual hydrant. System means, suppose, for example, if you have 500 number of hydrants, so the one which is controlling those 500 hydrants is nothing but our system. So here it is talking about that particular system. But here they have given the maximum and minimum pressure at each hose connections. Okay, at each hose connection they have given the maximum and minimum. So what I will do, I will just write down one table for you. just to understand this. Suppose we have three classes, class 1, class 2. Okay, you can skip class 3 because class 3 is a combination of class 1 and class 2. Class 1 is 65 mm and class 2 is 40 mm. So let us see what pressure ranges they have given for class 1 and class 2 type, minimum and maximum pressure. So first, minimum pressure.
This is at the hose reel, right? At the hose
Yeah,
reel.
at the hose reel. Second point is the maximum pressure. So let us see what they have given for these 2 points. So here you see where the residual pressure at a 40 mm outlet exceeds 100 psi. Okay, exceeds 100 psi means I'm expecting that the maximum pressure for 40 mm is 100 psi because here it is telling exceeds 100 psi. So what we have to do, an approved pressure regulating device shall be provided to limit the residual pressure. Now, yesterday you asked the question in the last class that at every hose reel they are providing PRV. So this is the point actually. If the pressure is exceeding 100 psi, then you have to go with the pressure reducing valve. And here it is given one point where the static pressure at a hose connection exceeds 175 psi. An approved pressure reducing shall be provided to limit static or residual pressure at the outlet of the hose connection to 100 psi. See, both the points are confirming that the maximum pressure at 40 mm is 100 psi because here also it is telling that if the pressure is exceeding 175 psi, we have to limit to the 100 psi only. Okay. Now next you see, till now we got only one point. 40 mm maximum pressure is 100 psi.
That one now is
Yeah,
6.9 bar. That one for the outdoor hydrant, right?
Yes. Still we are left out with
6.9. 6.9.
Just go a little bit down. Okay. So many things are written here which I don't feel is required. Now here they have given location of hose connections. Hose connection and hose station shall be unobstructed, shall be located not less than 3 feet or more than 5 feet. Again, why they have given this point means because any person can easily accessible it. Even if a small boy, in case of fire, they can come and they can like access this hose location. Now, class 1 system, they have given the locations also. See, these are the location at the main floor landing in exit on each side of the wall adjacent to the exit opening of the horizontal. Suppose if you are going in a mall building, in each exit passageway, the entrance from the building, in covered mall building at the entrance to each exit, etc., etc. At the highest landing or stairway, some things are given here where you have to place. Mostly we are placing near the staircases or in the corridor areas. We place sometimes near the lift lobbies also we will place it. So this is one thing is given. And class 2 system shall be provided with 40 mm and so that the portion of each floor are within 130 feet. See, 39.7 meter is given. So it means that the maximum hose length you can go up to 39.7 meter as per this point. So you can go up to 40 meter also. So this is one point given class 3 system. They have given some point about class 3 system also. And same they have given 39.7 meter also. This thing you leave this. These things are not required for us actually. Some clauses are given. Now, this is
also on the side, they're giving the hose 30 meters.
Yes. Here you see, this is also important point. Class 1 and class 3 standpipe shall be at least 4 inches in size. The minimum size we need to follow is 4 inches. Standpipe that are part of a combined system shall be at least 6 inches in size. The meaning of combined system means sprinkler and hydrant system. If you are having sprinkler and hydrant system, so at least it should be 6 inches, 150 mm. Or otherwise, if you are feeling that the sprinklers are more, hydrants are more, you can increase the pipe size also. Like you can make it to 8 inches also. This is the header pipe. Okay, this they are talking about the header pipe. And here they have given something where the building is protected throughout any in accordance standard for installation. The minimum head standpipe shall be 4 inches for system. Okay, leave these points. Now you see here they have given the minimum maximum pressure limit. We were talking about the pressure limits. Now here they have given the minimum and maximum pressure limit. Now you see, first they have given about the minimum pressure hydraulically designed standpipe shall be designed to provide the water flow at a minimum residual pressure of 100 psi. See, minimum pressure of the 100 psi at the outlet of the hydraulically 2.5 inches. Now, second point we got as the minimum pressure of 65 mm is 100 psi. Okay, as per this point, this is the minimum pressure. See, at a minimum residual pressure of 100 psi at the outlet of hydraulically most, and 65 psi at the outlet of hydraulically 40 mm. 65 psi is the minimum for 40 mm. So we got 3 points: the minimum pressure and maximum pressure for 40 mm outlet, and the minimum pressure of 65 mm. Now, can you tell me what will be the maximum pressure for 65 mm? Because nothing is given about the maximum pressure. Here you will not find anything about the maximum pressure. I think we will not find about the maximum pressure. But if you go a little bit above, you will find the maximum pressure written here. See, 175 psi, where the static pressure of at a hose connection exceeds 175 psi. So I understand that this 175 psi, it is talking about this 65 mm only. So these are the pressure ranges of the hose connection: 100 psi to 175 psi.
But how is it possible to get, if the system maximum system pressure 170 psi, is it possible to get at the hose reel 65 mm also 175? There is no pressure
You
losses
can
in the
use
full pipe?
you can use the pressure reducing valves. Pressure reducing valves you can use, but this entire system pressure they have given 350 psi. So maybe like this 350 psi will only like happen for the high-rise buildings, because 350 psi is very huge pressure. But overall building, if you are talking about complete combined system, hydrant and what you can say a sprinkler, then I think we should go with 175 psi only, because
all the projects you will find the discharge wet reserve combined for sprinkler and hose reel.
yes, combined only. And I think we will never get this pressure, so we don't need to bother about this pressure. But
there is a dry riser for the breaching inlet for the fire department, but it has been cancelled nowadays in Abu Dhabi.
Yes, at least as a design engineer, you should know these pressure ranges. So till now, we have just cracked on these pressure ranges. In the same way, they have given some section about the flow also. If you come little bit down, they have given about the flow rates. Simply here, what is given for class 1 and class 3, the minimum flow rate for the hydraulically most remote standpipe shall be 500 GPM through 2 outlets. That means one hose can have 250 GPM of water. Okay, because here they have given through 2.5 inches. So just divided by 2, you will get 250. So class 1 and class 3 system is nothing but 65 mm is the class 1, and combination system is the class 3, 40 and 65 mm. And here they have given some points, see, where a horizontal standpipe on a class 1 or class 3 supplies 3 or more hose connection, the minimum flow rate for the hydraulically most demand shall be 750 GPM, and the calculation procedure shall be according with some point. Here what it is telling.
What is the difference between the 500 GPM and the 750 GPM? What's the difference?
Difference is that here they have mentioned 3. Here they have mentioned 2. If you divide by 2, you will get 250. If you divide by 3, you will get 250. One standpipe system.
What is this 2 inch and a half? For what this 2 and a half? For what this 2? 2 pipes?
2.5 inches. This is the hose connection, 2.5. It is telling that simply it is telling that whenever in one floor you go with 2 hose connections, and the hose connection size is 65 mm. Just this is my understanding from this point. For class 1 system, the minimum flow rate what we need to maintain is we have to go with 2 hose system, and the minimum flow rate we have to maintain is 500 GPM. Just according to this point. And the most important point, okay, and this point you leave it because this is little bit confusing. The minimum flow rate for additional is 250 if it is exceeding 18,000 square feet area. This is very confusing. This is the most important point. Okay, because this point is the, I think this is the entire what you can say, this particular point is the entire what you can say water flow capacity requirements. What it is telling here, the maximum flow rate shall be 1000 GPM for buildings that are sprinklered throughout in accordance with NFPA 13, and 1250 GPM for buildings that are not sprinklered throughout. Now, can you tell me what do you understand by this note? What do you understand by this note? The maximum flow rate shall be 1000 GPM for buildings that are sprinklered throughout, and 1250 GPM for buildings that are not sprinklered throughout.
Sir, is that the flow rate defined by the defined to the pump system?
Yes, yes, exactly. It is defined to the pump system. Now, whenever you are having only sprinklers, okay, sprinkler throughout means whenever you are having only sprinkler system, then you have to use, this is the maximum flow, 1000 GPM. If you have my sprinkler plus hydrant system, you have to go with 1250. Remember, it is talking about the maximum flow rate. We don't need to forcefully put 1000 GPM. If your calculations are coming 700 GPM, take 700 GPM. If your calculations are coming 1150, bring it down to 1000 GPM. Whatever the building, whether it is 1 floor, 2 floor, 100. This is the maximum.
Later, later you will teach us how to calculate the GPM of the pumps.
Allied software will automatically teach us how to do the GPM calculation, because Allied software will automatically calculate the software, this thing. Everything it will calculate, the GPM, how the GPM is distributed, everything it will calculate. We just need to follow certain steps. So why I'm like taking this much of time in this particular books means because here everything is written. If you understand this thing, then you will feel very easy to do the what you can say hydraulic calculation or allied software calculation, because everything's are written here only in NFPA 13 and NFPA 14. After this point, they have given something about
Sir,
hydraulic
for
calculation.
the extraordinary hazard, it will go beyond 1250 GPM for extraordinary hazard.
No, it will not go, because
It may go above 1250. Not sure now.
it can never be approved, because that point is clearly written there that you have to follow. See, if you are exceeding means you have to go with another source. Okay, you have to go with another fire source. This is for one fire source, or it is for one fire tank. This capacity is for one fire tank. Suppose if your building is very, very vast, so you can go with certain different fire sources. Okay, like you will make one tank in the east location, one tank in the north location. Like that, you can distribute it. That's why the NFP has given the floor, what you can say, up to 52,000 square feet only we can use. One fire source we can go with 52,000. If the area is exceeding 52,000, or if you have very big floor areas, 2 lakh, 3 lakh, then just divide that by 52,000 and make that much of
4,831 meters.
Meter square. Yes, exactly.
In case of fire, we will calculate for one indoor working and outdoor hydrant 2 at the same time, right? Or I'm mistaken?
Yes, it's up to us. See, it entirely depend upon us how much what you are adding. That I will show you in the hydraulic calculation. Just let us quickly complete this. Now, hydraulic calculation and pipe size for each shall be based on providing 250 GPM at the two hydraulically most on the standpipe, and at the topmost outlet of each of the other at the minimum residual pressure required by. See, this point clearly it is telling that you require two hydraulically most remote hose connection on the standpipe. So with this point, we understand that the minimum fire hose connection requirement in one floor is 2. Means you have to add 2 hose connections. If you are adding 3, 4, that is very good. But minimum you have to add 2 points, 2 hose connections or 2 hose rails. There are so many different names: fire hose rail, fire hose cabinet, hose connection, hydrant system, internal hydrant system, anything you can call it as. And here, see, this point is again where a standpipe system has rather that terminates at different floor level. Separate hydraulic calculation shall be performed for the standpipe that exists on each level. In case flow shall be added only for standpipe that exists on the. These are very confusing points. Whereas horizontal standpipe on class 1 and class 3 system supplies 3 or more hydraulic calculation pipe size for each standpipe shall be based on providing 250 GPM at the 3 hydraulically most remote hose connection. And this point is also a little bit important. Here what it is telling that whenever you are having 3-4 hose connections, then don't bother about all the hose connection. Perform hydraulic calculation for 3 hydraulically most. This is the maximum point has been given. The minimum is 2 given, the maximum is 3 given. Okay. Here what they have given 2 hydraulically most remote hose connection. Here they have given whenever you are having 3 or more hose connections on any floor, go with the 3 hydraulically most remote hose connection. Okay, so this is my understanding. So you can go maximum 3, minimum 2, but I will recommend and I will suggest you that if you have any experienced engineer, okay, in your firm, just confirm this point with them also once, because as per this point, my understanding is that the maximum hose connection we can include in our calculations are 3 and the minimum we can include are 2. But I don't know how they are doing calculation for more than 3 or 4 hose connection. This thing you need to just confirm, because this is a very experienced level. Like any experienced person can only tell this particular answer. But I'm just talking about this NFPA 14, what they have given. Most of the project we have 2 hose connections. We have only 2 hose connections, because I have seen most of the time 2 only. Common supply piping shall be calculated size to provide the required flow rate. Okay, leave this. Combined system. For a building protected throughout by an approved automatic sprinkler, the system demand shall be permitted to serve the sprinkler system. Where the sprinkler system, okay, leave this. These points are not important. For a combined system equipped with partial automatic, the flow rate required by shall be increased by an amount equal to. Okay, these things are not required, because why we are skipping these points, because anyhow we are doing right calculation. In hydraulic calculation, everything will be visible to the client also. Like sprinklers will be there, hydrants will be there, yard hydrant will be there. So we don't need to bother about these things. We will be sticking to the Elite software only. They have given the minimum flow rate for 40 mm, which is 100 GPM. Like 250 GPM for 65 mm, 100 GPM for 40 mm. Hydraulic calculation requirement. Hydraulic calculation for each standpipe shall be based on providing. Okay, leave this. See, here they have given the sizing for the drain pipe. Okay. And here they have given maximum flow required from a 2.5 inch shall be 250 GPM. The maximum flow required from a 1/2 inch hose connection shall be 100 GPM. Some points are given. Okay, leave these points. And so many things are given which is not required for us. We can just go through that. Again, they will talk about the same hydraulic calculation, what we have seen in NFPA 13. Same Hazen-William formula and same equivalent pipeline chart. C values, Hazen-William formula, and K factor is not given. Water supply. Okay, hydrostatic test. Everything remains same. System acceptance. And nothing is like, everything's are same only. Whatever we have seen. System testing NFPA 25. And I think, see, the same acceptable arrangement, everything remains same only. So most of the things are given same in NFPA 13 and 14. This is one thing which is given, post-stream friction loss, but I don't understand this actually. Or maybe they have given the maximum pressure from this particular nozzle hose. Suppose if your outlet is like one valve outlet 250 GPM, and here they have given 2.5 inches combination nozzle with 150 feet. Suppose if you are using 46 meter of hose length and you have 2.5 65 mm, the GPM it is withdrawing 250 GPM. This is the maximum pressure. 123 should be the maximum pressure. In the same way, for 1.5 inches, 30.5 meter, this is the pressure 140. Like that, some pressure ranges are given, but I don't know. I think this is used for some manufacturing companies only. Maybe they will check this, because we are sticking with these particular points only: 100, 175, 65, 100. If we include these points, again we will get confused. A lot of confusion will create. So that's why we will just skip this. But if you get any chance to discuss with any manufacturer, you can discuss this point with them also. If they have knowledge, they can definitely tell about this. Rest, they have given one example here, like NFPA method has been given, how to do the calculation. Again, I don't feel this is required for us, because anyhow we are going to follow the hydraulic calculation. So this is something about the NFPA 14 and 13. So just remember till now what we have done.
Mr. Atif,
Yeah, tell me.
hello, can you hear me?
Yeah, I can.
In the hose reel cabinet, there is single and there is the double cabin. In the double cabin, you will have the hose reel, which is 40 mm, and you have also downside, like a landing valve,
Yes.
like a coupling, and there is big hose. Is this the combined class 3?
No,
Because
I will.
2 inch and a half is downside. Double cabin, you know the double cabin, right? Double cabin.
Yes. See, this fire hose cabinator, I will show you.
Double.
Yeah, tomorrow we will see some images and all about this fire hose cabinet. FHCs, sometimes it is called FHC also. So the same arrangement will be followed for each and every fire hose cabinet or headed system. So I will show you tomorrow some look at images.
But did you hear me when I said if there is double door cabinet?
That is double headed.
You will find the hose reel.
See, normally single headed, double headed is nothing, but double headed will be something like this. Suppose if you are using double headed, means one pipe can go here, one pipe can go here. Sometimes this also comes. So here what happens, this is 15 meter, this is 15 meter, or sometimes this is 30 meter, this is 30 meter, it depends. So if you are increasing the length, the price will also increase. So like that, I will show you some images tomorrow.
No, Mr. Atif, I fixed this one. There is double cabin. Upper half, it will be hose reel, the 1 inch hose or 40 mm. Downside, there will be 2 inch and a half, like a coupling joint with 2 inch and a half hose, 30 meters as well. And there is powder downside as well. Extinguisher.
Yeah, it can happen, but I haven't seen like that. Like one side you have 65 mm, one side you have 40 mm. I saw like this. One side is the hose, and the downside we have the fire extinguisher. Something like that I have seen. One side is the hose, and one side is the fire extinguisher.
Downside there's extinguisher, and there is also 2 inch and a half.
Okay, I haven't seen this kind of any image. If you have any, you can just share in the group also. Because
yeah, I will share it out.
Yeah, because in India, like usually we don't follow this. Like in India, usually we have 65 mm only everywhere, and I think in Gulf also they are following the same only, 65 mm only everywhere they are following. But anyhow, tomorrow I will show you some images also, and tomorrow in our tomorrow's class, we'll see some points about NBC. Now remember that this NBC is nothing but it is for Indian requirements only. Some minimum firefighting requirement as per Indian condition. So tomorrow I will be discussing this. It will not take much time. And after tomorrow, our main hydraulic classes will start. Okay. Like tomorrow, if anyone who doesn't want to do Indian calculation method, they can skip class also. Nothing will happen. But still, just we will discuss some points about NBC. Then we will directly jump into hydraulic calculation, because in hydraulic calculation, I think we will be taking much time. Like one day we will see the manual calculation. We will see the manual calculation also, and allied software, everything we will see. Because if you understand this hydraulic calculation, you can follow the same procedure for every system: wet sprinkler system, mist sprinkler system, foam sprinkler system. So everything you can follow, because hydraulic calculation is the universal method actually. Okay. So this is the universal method. And what you can say, if you understand a couple of examples in hydraulic calculation, it is more than enough for you to design. Because Normally in Allied software, we have to just input the values. Based on values only, software will never understand that you are doing for wet sprinkler system or foam sprinkler system. But if you know the exact values, like for example, if I am putting 100 psi, so I will understand that I am doing for 65 mm. Okay. If I am putting some different like 40, what is the minimum this given here? 65. If I am putting 65 psi means I will know that I am doing for 40 mm hose.
40 mm.
So software,
Class 2.
yeah, software will never understand you are doing for mist system, foam system. It is us who are deciding what, and the pressure ranges are given separately. Just remember this pressure ranges. Till now we have seen the pressure ranges for sprinkler and hydrant. In our like in our consecutive next classes, in the same way you will get some pressure ranges for mist system also, and I think you will get for foam system also. So you have to remember these pressure ranges, because based on the pressure ranges only our systems are going to vary, and obviously also the flow also you have to sometimes remember. So based like that.
Sprinkler, hydrant.
Yes.
What is the third one? Foam, before foam what?
Mist system.
Sprinkler, hydrant. What
This
is
the
the
mist system. That you will understand. We will see this later. Mist system is also one of the system. Foam system is also one of the system. And deluge system and pre-action, these are not system actually. Deluge system is just designed for one single
area
only. It is designed. It is a combination actually. Deluge system you can combine with sprinkler system. Deluge system you can combine with foam system. Deluge system you can combine with mist system. Like that you can go for whenever we are talking about the deluge. So like that we will see. Okay then. So we will stop here only today.
Hello.
Yeah, hello.
Sir, can you please share the software?
Yeah, I will share. Because I will share the WF file also, because it will, I know that it will take some time for you to download. So that's why, like, before going to the software calculation, we will discuss that only first, like how to download, install, because one web file will be there. So you need to download that web file. If you download this WF file, the 1000 node pipe will be activated, the 1000 pipe software. So that I will share you. Just we are going slowly, because everything if I share, so it will be very much difficult for you only. So that's why slowly we are going.
Yes, yes.
Okay. Okay then. Okay. Thank you.
Okay.
Thank you.
Thanks.
Thank you. I will stop.